Good afternoon, everybody. I hope that everybody is having a wonderful Tuesday. So I am going to share my screen here for just a moment so that you can see the webinar control panel. So this is what you're seeing in the webinar as an attendee. The first thing you're going to notice is that if you haven't, you are coming in on mute, and this is just to decrease background, audio issues. So you will remain muted. However, you can communicate with us via the question feature. So I just sent out a chat a moment ago and I said, good afternoon, everybody. And you can reply to that. And if you submit a question or a comment in the questions feature, then we can answer that. We are going to have a live Q&A with Brittany at the end of the presentation today. So please ask questions. She, is just a wealth of knowledge and is happy to answer them. So I encourage you to do so. I see, yep, hello, honey. I see people using the questions feature. Very good. Other than that, you are here to really sit back and just soak it all in. I'm just going over a couple of logistic things, and then I'm going to go ahead and pass it off to Brittany. The other thing that I want to mention is that you will get a follow-up email. The follow-up email does look like it's coming from me. It's just an automatic thing through the webinar platform. And in that email, it's going to say, thank you for attending in the subject line. I think it is set to be sent out several hours after the event. So if you'll have it no later than tomorrow morning. And in that email, you'll find the link to the recording. So if you click watch recording, it will direct you to the video page where you can watch today's recorded webinar. You can also click my certificate and it will download a PDF certificate of attendance showing that you completed this webinar with Hand to Mind today, for an hour. Oftentimes, administrators do give PD credit for those. So I encourage you to at least try to submit that for PD hours. That is up to your administrator, but we do provide the certificate. The other thing is that we will, come back and review this at the end. We're going to do a giveaway, so hang in there, stay on till the end, and you have a chance to win a daily math fluency kit. And before I pass it off to Brittany, I'm going to launch a poll quick. The poll is just going to ask whether or not you're using Math Talks and Number Strings in your classroom. Is this something that you are already familiar with and using? So go ahead and yes, you're here to learn more about that, or no, but I want to use Math Talks and Number Strings. And then I will pass it off to Brittany after I give you guys just a second to answer that. Okay, so we have about 70% in. That's pretty good. I would say it looks like about 60% are using and want to learn more, and 40% are not. So that is a great opportunity for us. Brittany, I'm going to go ahead and pass it off. I am going to drop a couple of documents in the handouts before the end of the webinar today, just for you to have more information on, the Math Talks and Number Strings and daily math fluency. And hopefully, that's something you can print or download and keep and reference as needed. So Brittany, let me go ahead and pass her off. This will be a great webinar, so I'm here if you need anything, but here you go, Brittany. You should get the request. Oh, here it is. Okay, taking me longer than usual. Okay.
Okay, let's see. Can you see my screen now?
Yes.
Can you see it? Okay, the right one with the hand.
Yep.
Okay, awesome. Okay, so thank y'all very much for joining us today. We are going to be talking about number strings and math talk routines. And this is for grade 3-5. We did K2 a couple of weeks ago, but thank y'all very much for joining us. I know that, if you are a teacher right now, you have had a long day at work, and I know that some of you are teaching virtually and some of you are teaching face-to-face. We will try to discuss strategies for both today, but we're really going to delve into this idea of number strings and math talks. So our goal today is really to empower you to know how to use number strings and math talks in the classroom. And so my name is Brittany Goerig. I have been with Hand to Mind for a couple of years, but before that, I was a classroom teacher for 17 years, where I taught grades 1 through 4. And then my very last year, I decided to become a 7th grade math teacher. So what we're going to be talking about today are things that I've done in my classroom. So a lot of those experiences will come out in this. After I was in the classroom, I was also an educational consultant for our regional service center here in Texas, where I worked with teachers and students, got to still go into classrooms and do some model lessons where I did these same things of number strings and math talks. So very glad to be here today, but really I want you to know how to use these in your classroom, whether that's virtual or face-to-face. So we have a pretty jam-packed agenda, as you can see right here. We are going to talk about what a number string is, but we're going to do that really quickly because I've done other webinars where I've really defined that out. We're going to define it, but we're not going to spend very long on that. What is a math talk? Then we're really going to look at planning for a number string and planning for a math talk. And we will experience both because I think sometimes the best way to learn is to actually experience. So we're going to experience both of those. And then I'm just going to give you a few tips, just setting your class up for success, whether that's face-to-face or virtual. And then we're going to look at just something, resources that we have at hand to mind that can help with this as well. So let's just get started. What is a number string? Well, a number string is a series of related math problems. So you can see on that card that you see that series of problems. Those problems are all related to each other in some form or fashion. And when we experience that, we'll talk more about that. And then what you're going to notice is that a number string is always focused towards a strategy. So its goal is really to help construct strategies with students. So we have a lot of strategies we want kids to know and understand, but we really want to take time to help kids construct it instead of us just telling and talking at them. So number strings do a really good job of this. Also, number strings really encourage students to be efficient. The teacher strategically chooses who shares. We'll talk more about this as we experience it. And the last thing about a number string is that the teacher actually models the students' thinking. So the students are doing the math, but the teacher is modeling it for the other students so that everybody can join in on this conversation and understand how everyone's thinking about certain problems. So this is intended to be a 10 to 15-minute routine. Pam Harris says this best about number strings. She calls them problem strings. But what she says is that problem strings build relationships and connections in learners so that strategies become a natural outcome. I love that quote because that's exactly what a number string does. If you don't want to have to sit in front of your kids and just tell them how to do something, a number string will help kids actually construct it and take ownership of it. The next thing we're going to talk about today is a math talk. And so when I look at a math talk really is just one problem. It's one problem that the goal is to see what strategies are kids going to come up with. So it's really about eliciting these multiple strategies with students. And then it's also about promoting student discourse. So it's really about facilitating rich discussions with our students. But the focus on a math talk is more about giving kids opportunities to choose strategies. So a number string constructs strategies, whereas a math talk focuses and gives kids opportunities to choose strategies. So that is really important to remember when you're thinking about which one to do in your classroom. So that's what we're going to talk about. We're going to talk about like, which one do you do? Or when do you do it? When do you do a number string? When do you do a math talk? So a question I always ask myself is, what is the mathematical goal? So what is your mathematical goal? That's going to help you determine whether you want to do a number string or a math talk. So here's a question. If your goal is to really help students construct computational strategies, if you are wanting kids to take ownership of that strategy and really have a deep understanding of that, if that is the goal, then what we want you to do is going to be a number string, and we'll talk more about that. But if your goal is to provide students opportunities to see a variety of strategies and compare strategies for efficiency, that sounds more like a math talk. So that's exactly where I start. I ask myself that question. What's my goal? Is my goal to construct computational strategies? If so, I'm going to do a number string. That is where we are going to start. We're going to start planning for a number string. We're going to take the stance that we want to help our kids construct strategies. So what has to happen when we plan for number strings? Well, we have to think about what we're trying to construct. What kind of strategies are we trying to construct? Are we trying to construct additive strategies? Strategies where we want kids to think about numbers in their parts or in their chunks? So let me give you an example of an additive strategy. If you ask somebody, what's 99 plus anything? So I could tell you 99 plus 37. What does that look like additively? Well, one way that looks like additively, it would be thinking about 99 is really close to 100. I bet you a lot of people are thinking of that. Yeah, it's really close to 100. So I could just do 99 and 1 gets me to 100. I have 36 more. I'm at 136. Or some of you may be saying, no, I'm going to do 100 plus 37 is 137, and I'm going to adjust one, and that's 136. Either one of those strategies is thinking additively, because now you're thinking about your numbers in their parts or in their chunks. But you may be working on what we call multiplicative strategies. In grades 3-5, this is really beginning to start in grade 3, where when we're thinking about multiplication or even division, we start off with this idea of skip counting and repeated addition. And that's a great way to start, but it's not where we keep kids. Those are additive strategies. We want to get kids to think multiplicatively with our multiplication. So what do I mean by that? Well, I mean, a kid who's thinking multiplicatively for 6 times 7 is saying, oh, I know that's 42 because I know 6 times 6 is 36 plus another group of 6 is 42. Now they're thinking about their numbers they're thinking about groups, and they're thinking about groups within groups. That is multiplicative thinking. So we got to remember what we're trying to construct here, because that's going to help us know what strategy we're going for. So what does this look like? So if I was to plan a number string, remember, I'm planning a number string. I'm thinking about what strategy is it that I want to help my students know and understand. And so I might do this number string that you see on the left-hand side. So you see a series of related problems, 10 times 4, 5 times 4, 6 times 4, 7 times 4, 6 times 8. So I'm really trying to construct that strategy that's at the top where it says use 5 times. So I really want to help kids construct a strategy where they are using their times 5 to help them. So I would like for you to think about, because this is how I would plan it, would be think about what is it going to sound like when I do this number string with students? What is it going to sound like when a student uses the target strategy for 6 times 4? What does that sound like if they're going to use times 5 to help them? So if you would take a moment and just put in into the chat box some ways that you might think about what would it sound like if a student was using times 5 to help them for 6 times 4. What would that sound like? So take a moment to do that so I can kind of read those. Oh, I love this one. So somebody said, well, one way that sounds like is that you're thinking about 5 times 4 is 20, plus another group of 4 equals 24. Yeah, that's really kind of nice if I know those 5s. Nice. I see other people, nice. Some of the same things. 5 groups of 4 equals 20. So one more group of 4 is plus, one more group of 4 plus 20 is 24. Nice job. Wow, we have a lot of multiplicative thinkers in here. Okay. Ooh, this one I like. Said, you know what I would do is 6 times 5 is 30, and 6 less than 30 is 24. That's a whole nother way of thinking about times 5, right? So you're thinking about 6 times 5, and then you're subtracting a group. Wow. So y'all are already thinking multiplicatively. This is what we want kids to come up with, right? So here's my example of what this might sound like in a classroom. So a kid might say 24. It's just one more group of 4 from the previous problem. If I know 5 times 4 is 20, then 6 times 4 is just one more group of 4. It's 24. That's what a lot of you are saying, right? That's kind of that goal. I need to know before I do a number string what it is I'm hoping to hear from one of my students. So then I know where to guide them. Okay, so that's the first thing. Always think about what is it going to sound like when a student is going to use that target strategy when you're planning. Okay, the next question I ask myself is, how will I actually model students' thinking when they explain the target strategy? What is that going to look like? So what is it going to look like when I model these problems? Well, it depends on which kind of model I'm choosing, but here is something that I've done because I knew ahead of time what I was going to use. So for this number string, I'm going to use pictures of groups. And so this might be what my board looks like when I'm done. I've thought through how my board is going to look when I'm doing this number string. This is something I do in the planning phase of a number string. I want to write things down so that I know where I'm going with this. So you can see that when I thought about 6 times 4, well, what is that going to look like when a kid says 5 times 4 plus another group of 4? So here's a way I can group those 5 groups of 4, and then I can see that other group. So there's 20 plus 4 equals 24. And then I might write it out this way. So these are things that I think about before I ever do that number string with my students. Then another question I ask myself is, what strategies do I anticipate students will use for each problem? So I look at these and I think about, like, what might they use? So I want y'all to think about that. If you are giving your kids problems like 6 times 4 or 7 times 4, what strategies do you think they would use? We know the target strategy is used 5 times. But we also know that kids are coming to us where they are, and that's what we want them to start with. So what other things might they think about? Can y'all add that into the chat box? I see somebody saying doubling numbers. Absolutely. I see someone saying, oh, they might draw some pictures, circles and stars, repeated addition. Absolutely. Those are definitely things that kids are going to do. Anything else? Jumps on a number line. Absolutely. They're going to do that repeated addition or repeated skip counting on a number line. They're going to use that model. They might use skip counting and singing. Yes, all of those things are things that kids might do when they do that. I want to anticipate that. I want to think about what my kids might do, because here's the ones that I came up with that I thought about. Skip counting, repeated addition, y'all saw that. Using 5 times, I think somebody will do that. Talking about 5 is half of 10. Using doubles, someone came up with that one. But those are the ones that I'm thinking I might see. Y'all had a lot of other ones, and I don't doubt that those would come out too. But here's what you have to remember about a number string. What strategies are you going to model, and which ones are you not going to model? Because here's the thing. In a number string, remember, it's a 10 to 15 minute routine, and it is focused towards constructing a strategy. For this one, it's focused towards using 5 times. So I'm going to be very careful about choosing which strategies I'm going to model. It's not that a student can't share their strategy. It's just that I may not model that strategy. So I want us to think about that, because in a number string, it's not about everyone shares. I am really trying to construct a strategy, and hopefully you'll see that in just a minute as we experience one of these. So this is what I would say. When I'm thinking about strategies, I'm modeling using 5 times, because that's obviously the one that I'm going for. Anytime they're using any type of partial products, which is part of using 5 times, those are things that I'm going to model. I'm going to model if a kid talks about that times 5 is just half of 10. I'm definitely going to model those types of things. But that's pretty much where I'm going to stick when I'm modeling. So here's what we're going to do next. We are going to actually experience this exact number string that you just saw me plan for, okay? So what I'm going to do is I'm going to flash up a picture. I'm going to leave it there probably about 3 seconds to give everyone time to do this, okay? And then I'm going to flash it, and then it's going to go away. And I'm going to ask you 2 questions. So how many, and then how many, and then how did you see it? Okay, so those are going to be the 2 questions I'm going to ask you. Okay, y'all ready? Here we go. So how many? If you want to put it in the chat box, you go right ahead. You can do that. And if not, that's okay too. But I do want you to try to think about how many did you just see? So how many of you said that you saw 40? So some of you may say that you saw 40, and some of you may say, no, that's not what I saw. I saw something else. So I love all these things coming in, and I can see them. So in a classroom, it might sound like, and I wonder if it sounded like this when you were doing it. So let me get my pen real quick. So I might have a student say, well, I saw that there were 5 groups of 4 on the top row, and I know 5 groups of 4 is what? 20. And then I just doubled that because I knew it was the same, and that's 20. And I know that 20 and 20 equals 40. So this person used their doubles, didn't they? They used their doubles to think about that. They thought about 5 times 4, and then they just doubled that to get their 40. That is a way that a kid can do it. Another way that I've heard kids do this is they say, well, you know what? Sorry. You know what? I know that 10 times 10 groups of 4 can be thought of 4 groups of 10 or 4 tens. Now I know what 4 tens is. 4 tens is just 40. So that's another way that kids might explain that to you, okay? So let's go to the next one. Y'all ready for the next one? Here we go. Ready? How many? So how many did you see? I wonder how many of you were like, well, I see that all you did is leave that top row. There's that 5 groups of 4. And I already know that that's 20 because what we just had was 10 times 4. And what we're doing is we're just taking, we're just taking half of that. And so that's just 20. So we can think about 5 times 4 as just 10 times 4 and just take half of it. That's a really nice way of thinking about my 5s. Now I'm gonna confess to y'all, I told y'all I taught grades 1 through 4, and when I was working on multiplication with my kids, I wanted to construct these strategies, these multiplicative strategies with students. And I did a really good job with like the 4s and 8s and things like that. But when it came to 5s, my kids could skip count really fast. And so I kind of sometimes left them there. And what I know now is that just skip counting by 5s, and if I leave them in skip counting, what that does is that keeps them back in additive thinking. And I'm trying to develop multiplicative thinking for them because that's what they're going to need as they progress through their mathematics and go into middle school. So I want to think about how can I think about multiplicative strategies like 10 times 4 divided by 2 or taking half of that. That's a great way of thinking about times 5. It's just times 10 and then I take half of it. Kids love times 10. Okay, so let's do another one. Y'all ready to think about this one? Here we go. Here we go. How many did you see? How many of you were like, well, I saw 24 because I already know, we've already established that this is 5 times 4, and we know that this is 20. And all we're doing is adding another group of 4. So what we're saying is we have 6 groups of 4, and we know that 5 groups of 4 is 20, plus 1 more group of 4, which is 4. So 20 plus 4 equals 24. Wow, I can think of times 6 as times 5 plus another group. That's a really nice way of thinking about this. Okay, so let's see. Here we go. Let's try another one. How many? So how many did you see? I wonder how many of you are like, there's that 5 times 4 again. I see that 5 times 4, and I already know that's 20. But this time, I have 2 more groups of 4, which I know is 8. So I wonder how many of you said, well, I know it's 28 because I have 7 groups of 4. And I know 7 groups of 4 can be thought of as 5 times 4 plus 2 more groups of 4. So now we have 20 plus 8 is 28. Now I want y'all to remember that I'm not expecting kids to be able to write all of this right now. What I'm doing is modeling for kids their thinking. So remember, kids are just seeing this and they're probably not, they could be writing down an answer or they could be thinking about that answer in their head. But when they're explaining it to me, then I'm going to break it down into those pieces that they're seeing and help them make that connection. Okay, so let's do, we have one more problem that I want to do. So we're going to erase that. We got one more problem. Are y'all ready? Here we go. Here's our last problem. Okay, I let that one stay there longer because some of you are like, hey, you didn't have tomatoes up there anymore. No, I didn't have tomatoes up there anymore. I had color pencils, right? So this is called our clunker problem. So the other problems that we just did, they were very systematic. They were related to each other. I was building upon them. Now I want to give them a problem that is a little different, but it's still similar. Do we see 5 groups here? I wonder how many of you said, well, there's still 5 groups, but this time it's 5 groups of 8. So I know that's 40. And then I have this one group of 8, and I know that's 8. So I know my answer is 48, which is the same as 6 times 8, 6 groups of 8. Or I can break that down into how I thought about it, which was 5 times 8 plus one more group of 8, which is 40 plus 8 equals 48. If this was in my classroom, I'm looking for a student who's using this 5 times for this problem. Now, that does not mean everybody at the end of this is going to be using 5 times by the end, but they have seen problem after problem that I have been talking about, and I've been stressing about this idea of using 5 times. So this is the number string you just experienced with me, okay? It was a series of related problems. It was very purposeful that I started with 10 times 4 to establish the 5 times 4. I was looking for who was thinking about half. Then I went to 6 times 4. I'm looking for the student who says, well, I know 5 times 4, I'm just adding another group of 4. And then it goes to 7 times 4. I'm looking for the student who's still using that 5 times 4 and now just adding 2 groups of 4. And then I'm doing 6 times 8, and I'm looking for the student who sees the 5 times 8 plus another group of 8. That is helping construct this idea of using 5 times. So those were the questions that I asked, and I had the goal of what it might sound like for a student to do that. And then I have also what it might look like if a teacher is modeling it. This again is a 10 to 15 minute routine. Now, let's think about the next thing. So we've done number strings. We've constructed strategies with our students. Now we need to talk about what if the goal, though, is that we want to give kids opportunities to choose strategies and really compare strategies for efficiency. That is when we want to do a math talk. That's the purpose of the math talk. This is going to be the opportunity that I want to hear from everyone. I want to hear about all the ways that you think about these numbers. So what does this look like? Well, let's suppose I'm planning a math talk for 8 times 7. So this is the problem I'm going to give my students is 8 times 7. One of the questions, the first question I'm going to ask myself is, what strategies do I think students are going to use for this problem, or for each problem, for this problem in particular? So I want y'all to think about, how might your kids do 8 times 7? Will y'all go ahead and put that in there in the chat box so that I can see, like, what would your students do if they saw 8 times 7? What are some things that you might see? I'm trying to get down to y'all's. Oh, nice. Okay, so I see somebody say 8 times 8, and then they're going to subtract that group of 8. Nice. Oh, 5 times 7 plus 2 times 7. 8 times 5 times 8 times 2. Oh, y'all have some awesome multiplicative strategies. I'd love to visit your classroom so I could see your students do all of those things, because that is awesome. So you have some really nice ways of thinking here. Use repeated addition. Thank you. You're exactly right. You're going to see somebody do that, right? Love this. Okay, so y'all have some awesome ways of thinking about this. Doubling, and then subtract. Awesome. So here's just some I thought about. Using 5 times, using doubles, double and half. I don't know if I saw that one, but somebody might have had it. Using 10 times, using partial products in different ways. repeated addition definitely will be something that I see. So these are just some. Y'all came up with some awesome ones. I love all the ones y'all came up with that y'all did. Skip counting. I could totally see a kid, depending on what grade level I am on, in doing this. So the next question I ask myself is, what strategies will you model and not model? So again, I'm going to model repeated addition depending on where I am in the year and depending on what grade level I am in. And one reason why I will model repeated addition a lot in a math talk is because I'm going to talk a lot about efficiency. And I want the kids who are using repeated addition to recognize that they did get the same answer, but they worked really hard to get to that answer. And some of these other strategies take a lot less time and less steps. And I want them to start to compare and connect those. And we're going to talk about that. I'm going to model using 5 times, 2 different ways, which I think I saw that in y'all's. I'm going to model doubling. I'm going to model double and half. I'm going to model using 10 times. All of those I'm going to model. But then I'm going to think about, how am I going to model that? What type of model, what type of tool am I going to use to model that? So I actually did mine. So you can see here. Again, you can see the repeated addition. So I've modeled that. You can see I've used an area model for some of these. You can see I used a ratio table for some. These are all great models that help kids make those connections and make that learning visible. But I have all of my different ways. Up here, I've got my double and half using my area model. I've got all those doublings right there. So this is just some ways that I think about that. But then I'm also going to think about, what connections between strategies am I going to bring out? Because part of a math talk is helping kids make those connections. So here's a question I might ask, because I want the kid, again, who's doing the 7 plus 7, the repeated addition, to ask themselves, where is the 5 times 7 and the 2 times 7 in the repeated addition? So couldn't I just circle 5 groups of 7 and then circle the 2 groups of 7? Yeah. How are you using 5 times, and how is using 5 times and using 10 times similar? So how are they similar? How are they different? How are we using double? And how are we using how are double and half similar? So how are these 2 strategies? How are they similar? How are they different? We're going to have those conversations so to help kids articulate those things. We're going to talk about, when we look at these strategies, which strategies are really efficient? So which strategies take us few steps? So using 5 times is one that I see. Takes really 2 steps to put it together. Using 10 times or doubling. So this using 10 times and then just subtracting the groups, or doubling each time. So using things I know. Double and half is another really efficient strategy. Any type of use of partial products. These are examples of using partial products, but in particular using the 5 times. So let's just do a math talk real quick. What if I gave you 9 times 8? How would you do 9 times 8? Can you put that in the chat box and just explain to me how you would do 9 times 8? So when you look at those, what relationships just jump out? What do you see? Lots of different ones in here. I love that. I hope you're all kind of looking and seeing how everyone's thinking about it. So I've just chosen a few. Y'all have some great ones up here, but I wonder, and I think I saw this one on somebody's, the use of 10 times. So why not think about 9 times 8 is 10 times 8, but then just subtract a group? That's a nice way of doing that. Or what about this? What about using 5 times? So you're going to think about, we can think about the 9 as 5, 2, and 2. Or double and half. So doubling one factor and halving the other factor. So then we get to 18 times 4, and that might be easier for us to do because I can double. Or just doubling, using the idea of doubling. So if I double the 9 and then I double the 18 and I double the 36, I can get 72. So double. Those are all ways, and I saw lots of those in here. And y'all had some other ones that we could have definitely done. But that is an example of a math talk. So when planning for a math talk, we're talking about one problem. We're talking about thinking about all the different ways that students might use this. And we're thinking about how are we going to facilitate that rich discussion and help kids make those connections to what they're already doing to maybe something more efficient. Again, a 10 to 15-minute routine, this is. So we've talked about a number string, we've talked about a math talk, but something that's very important is that in order to do these, we really have to set our class up for these. We have to have strategies to set our classroom up for success. So the first thing we want to recognize is that students should use what they know to solve the problem. So whether that is they are in counting, some of your kids may be counting. So if your kids are using repeated addition and you see this, because I did in my 7th grade classroom, so for 6 times 7, this is what I saw. I saw 6 plus 6 is 12. And then after that, I saw 13, 14, 15, 16, 17, 18, 19, 20, 21. I saw rapid fire counting. If that's where they're starting and that's what they know, that's okay. That's where they start. That's not where we want to end. But this is very important that we help kids recognize that they have to use what they know to solve a problem. Some kids may have additive thinking. So maybe all they have is skip counting for multiplication. That's additive thinking. That is where they start. If you're a 3rd grade teacher, please make sure you hear me. That is definitely where you start. Repeated addition, skip counting, those are perfectly fine. But what I want you to also hear is just don't leave them there, okay? Because then they get to 7th grade and they're still doing repeated addition and skip counting. And so we don't want to leave them there. And then some of your kids may already be in this idea of multiplicative thinking where they're thinking about groups within groups. And if they are, then my suggestion is, how can they think about other strategies that are still multiplicative? Because a lot of kids latch on to certain strategies. So we want to make sure we give them a variety of strategies that are efficient to solve these problems. Something to think about when you're setting up your classroom is you want, when you're doing a number string or a math talk, is really establish a discrete signal to use with your students to let you know that they have an answer to a problem. And so a way, face-to-face or virtual, is just to use their thumb at their chest and over their mouth. Or over their mouth. So here's the thing. In 2nd grade, my kids actually put their thumb over their mouth because my kids had a tendency to pop out their answers. If you're face-to-face or you're virtual, you can still do that if you can have cameras on and you can see your kids. If you can't see your kids, then that's not an option for virtual. But if you can, I just reiterate to kids, hey, your thumb has to be where I can see it in the camera. I can tell you that I wait a long time to do this. So I do not just wait for 1 or 2 kids to have an answer. I'm waiting for most of the class to have an idea of an answer. I can tell you that the silence can be uncomfortable at times, but the kids learn that it's okay and that, it's okay. And that's why we put it to our chest so that people around us aren't necessarily seeing who we're waiting on, okay? If you are virtual and you have the reaction buttons, you can have them put that reaction. It's not as discreet, but they can put a thumbs up, and that just tells you that they have an answer for you. Or you can have them do it on a whiteboard and show your screen. You know, there's different ways to do that. Just to flash it up there that they have an answer. The other thing that we would talk about, which we just talked about, but is really that teacher provides enough wait time until most students have an answer. I cannot stress this enough. We have to wait on our students. Some students are quick, some students are slower than others, but all of them deserve the time to think. If you've got a kid who is what I call a toaster, they pop out their answers. You have other kids in your classroom, I would be one of them, that I would call myself a crock pot. I need to simmer a little bit longer. But if that toaster pops that answer out, that crock pot turns off because they're like, oh, they already have the answer. So we have to set up that norm with our students that we are going to wait. We want to hear what you have to say. It doesn't matter whether that is repeated addition or skip counting or wherever they are, counting, wherever they are. We want to give them enough time to get to their answer. Another thing that is really nice is opportunities to turn and talk. So if you have students that are struggling talking out loud, then give them opportunities to turn and talk. If you're in a face-to-face classroom, this is much easier than it is in virtual. In face-to-face, I can do a lot of turn and talks if we're socially distancing or we have our mask on in those aspects, but they can talk about their answer to each other. A lot of times when kids can talk about their answer to each other, it's much easier for them then to express their thoughts to the class. Another thing to think about if you are virtual is during a math talk, you would have time to do this, but put them into breakout rooms. Let them have opportunities to talk with each other first. You can visit those breakout rooms, bring them back together as a group, and then have the math talk. Okay. So the other thing to think about is that we have to model this for our students. So we have to help kids understand, what does this sound like to explain their strategy? What does it look like to think through? So you can think through an example with your students. You can have them practice with each other and give them guidance on what that sounds like. You can provide them with sentence stems to help them, but they really need modeling of this unless they've had a lot of work from previous year. But you modeling what this sounds like is going to help them with this idea. So first off, I want to tell y'all, thank y'all for joining us today, but all of what you've seen today, when you've seen the number strings and you've seen the math talks, these are things that Hand to Mind have to offer. So we actually think we have the tools to change this idea about using number strings and math talks in the classroom. So all of that planning, and you saw those things on those documents, I would still do even with our materials, but it makes it a little easier if you sometimes have a resource that already has it done for you. And so we have what's called Daily Math Fluency for grades 3. We have this K8 actually, but your grades 3, 4, and 5 that comes with, you get 120 number strings, 60 math talks, and all of the manipulatives that you would need as a teacher. So the teacher manipulatives. Or some of you may be going, you know, my kids in 3rd grade are really just struggling with basic addition facts. I wish I had a kit that worked just on basic addition facts. If that's what you're we have a kit called Math Fluency Intervention, where we have divided them out into basic addition and subtraction, multi-digit addition and subtraction, basic multiplication and division. So if you're a 5th grade teacher, you may be going, yeah, I wish, you know, my kids are struggling with basic multiplication facts. We actually have a kit that's just for basic multiplication and division. It is our intervention kit. It comes with 60 number strings and 30 math talks. So it doesn't come with as many as the grade level kit because it's very focused into a certain area, and it still comes with those the teacher manipulatives and actually student size manipulatives, not for every student, but for the teacher to demonstrate on. So those are two things that we have here at Hand to Mind to help with this idea of number strings and math talks. So I'm going to turn it over to Kristen to field some, to ask some questions that she's seen in the chat box, and I will try to answer some of those. So Kristen, I'm going to turn it over to you.
Okay. So the first is, can you just clarify the difference between a number string and a math talk?
Absolutely. So a number string is a series of related problems. So that was what we did with the tomatoes and the coloring pencils. So the 10 times 4, 5 times 4, 6 times 4, 7 times 4, and 6 times 8. Those are all related. And the idea is that it really helps kids start to construct a strategy. Whereas a math talk is really about helping kids, giving them one problem to look at. I had y'all look at 9 times 8. And really, when you saw 9 times 8, I just want to know, what relationships do you see? What strategies would you use? And this is an opportunity for kids to look at numbers first and decide what strategy is best for those numbers for them. And then we are going to elicit all those strategies to give everybody in the room an opportunity to compare, and how I can help them connect to each other, and we can talk about efficiency. So that's kind of the two definitions for those.
Great. And they said thank you. Very, very powerful and very interesting. Is this going to be digital?
So that we get that question all the time. So the only digital piece that I would say that as a digital aspect would be that you might want the picture cards to be digital as a digital piece, but we would never like display the whole number string. We only display one problem at a time. Right now we don't have that available, but you know, we that's just not something that we've done, but it is definitely something that we are thinking about how we can help make this more digital, for especially right now in where we are.
Absolutely. And we do, you know, we do have something called Braining Camp, which is a virtual manipulative. I'll put the link in the box here. And that is just a great way to be able to demo something. If you don't happen to have the manip in front of you, you know, you can use the virtual versions. They look exactly like our physical manips. What about, so I'm going to put a video in the chat box because I'm getting a couple questions around the video. The video that I have, the video from Springfield Public Schools, it is a number talk, which is what they call a number string, a number talk, right, Brittany?
I believe she did I'd have to go back. I think she did a math talk, but
okay.
Yeah.
Do we have one that has both?
We have a number string one, the one from Katie ISD that we did. I don't know.
Okay.
I think we have that. So, you know, y'all can email, we can give our email to please email us, and we can get you what you need as well.
Okay. I'm going to put her email in the chat box as well, and as well as mine, although I think most of you have mine. The only other thing is, it is available as a demo. So the Braining Camp is, if you have not signed up for a demo before, you can go to handtomind.com. You know what, I'll just put it in, it's /Braining Camp, and that button there, and it says sign up for demo or demo today or something like that. And that you can use an email and sign up. The only thing with that is that you can only do it once. So if you've already signed up for, you know, if you've signed up for one of the demos before, it will not allow you to do that with the same email. You'd have to use a different one. We do have a lot of different packages available as well. So you can get an individual license. You don't, you know, it doesn't have to be a classroom license, and kids can actually, you know, share those. So keep that in mind. I will again put the link here. The other thing I want to say is that I think that's it for questions. Let me make sure I didn't miss anything first here. I'm trying to do two things at once. Obviously, that doesn't work very well for me. Nope, it looks like we covered them all. Lots and lots of great comments. So great job, Brittany. Trisha Martinez is the winner today. So yay. She is, Trisha, I will reach out to you and, you can tell me what grade level kit you want. You have I'm going to send you a full daily math fluency kit. So yay you, it's always fun to win things. And here is the link to the math fluency. I did put the brochure in the handout. So that is the newest brochure for daily math fluency. It explains the program. You can also go to thehandtomind.com/math fluency that you see here. I did put Brittany's email in here, and I am typing in the braining camp right now. So thank you guys for coming. It was another great session. We will be going over 6-8 in 2 weeks. So 2 weeks from today at the same time, 3:30. If you're interested or know of teacher friends that may be interested, we encourage you to share. The more the merrier.
And that is the lead author of 6-8, which is Michelle Reinhardt. So it won't be me. So if you've seen me for K2 and 3-5, don't worry, it's not me for 6-8. It is Michelle Reinhardt, and she is an awesome presenter. I can't wait to get to hear her and continue to learn from her. So if you have some 6-8 friends, please let them know that she is going to be the presenter, and she is awesome. So you don't want to miss that one.
Absolutely. And we don't, we are, it's nice to do a secondary as well. So that's an audience where we're definitely excited to kind of get into a little bit more. But yeah, I don't think there's any more questions today, Brittany. So I think we'll wrap it up. But thank you guys again. Look for the follow-up email with the link to the recording as well as the certificate. If you have questions, reach out anytime. We're always here to help. And we hope everybody has a good rest of the day.
Yes, thank y'all very much. We appreciate it. Thanks.